Hello friends, I am Manjudeep studying in Sri Venkateswara College of Engineering, Bengaluru, CSE stream, first year. Today my presentation is all about nuclear power plant, which is a topic from the subject Introduction to Mechanical Engineering. Let's start our video. So this was my introduction. The subject is Introduction to Mechanical Engineering, subject code BESCK 204D, and the topic is Nuclear Power Plant. Introduction. So nuclear power plant has been a significant source of electricity generation for several decades. In this presentation, we will explain what nuclear power plants are, how they work, their benefits, drawbacks, and their role in the future of energy. So what is a nuclear power plant? A nuclear power plant is a facility that generates electricity by harnessing the energy released from nuclear reactions. These reactions occur in the core of a nuclear reactor, where the nucleus of an atom is split, known as nuclear fission. So the primary fuel used in most nuclear power plants is uranium 235. So there are two types of nuclear reactions: nuclear fission reaction and nuclear fusion reaction. So nuclear fission reaction. So definition. So nuclear fission is a process of splitting the nucleus of a heavy atom, such as uranium 235 or plutonium 239, into smaller nuclei, along with releasing of neutrons and substantial amount of energy. Along with the releasing of neutrons and substantial amount of energy. So nuclear fusion. The definition. Nuclear fusion is a process of combination of two light atoms, atomic nuclei, typically isotopes of hydrogen, deuterium and tritium, to form a heavy nucleus, releasing an enormous amount of energy in this process. So in the picture you can see nuclear fission and nuclear fusion reaction. The fusion reaction process, heavy atom has been split into smaller nuclei, and in nuclear fusion reaction, small atoms or isotopes have been joined together, combined together to form a bigger nuclear atom, heavier nuclear atom. An enormous amount of heat is being released during this process. So difference between nuclear fission and nuclear fusion reaction. Nuclear fission. So in nuclear power plants, controlled nuclear fission is used to produce heat, which generates steam to drive turbines and produce electricity. In nuclear fusion, so fusion is the process that powers the sun and other stars, where immense heat and pressure creates the condition for fusion reaction to occur. Nuclear fission. So the process is self-sustaining under specific conditions. As a released neutrons can trigger further fission reactions, creating a chain reaction. Nuclear fusion. If achieved, nuclear fusion could offer a nearly limitless, clean, and safe energy source with abundant fuel supply. Deuterium can be extracted from seawater. How do nuclear power plant works? A nuclear reactor is a device which controls a nuclear fission chain reaction to harness nuclear energy. A nuclear reactor which is used to generate electricity is called a nuclear power plant. So in nuclear power plant, the energy released by the fission is used to produce superheat steam. So this turns a turbines, which is turn operated an electrical generator. A nuclear power plant has the following components: nuclear reactor, cooling system, heat exchanger, the control rods, and steam turbine. Nuclear reactor. So the heart of the nuclear power plant is a nuclear reactor. It contains nuclear fuel rods made up of enriched uranium, and when a neutron strikes a uranium nucleus, it splits into two smaller nuclei, releasing an enormous amount of energy in the form of heat. Heat exchanger. So the heat generated from the nuclear fission is used to heat water to create steam. This process takes place in the closed loop system, which ensures that the radioactive materials does not escape into the environment. Steam turbine. So the high pressure steam produced in the heat exchanger process is used to turn a turbine, which drives an electrical generator, converts mechanical energy into electrical energy. Cooling system. So after passing through the turbines, the steam is condensed back into water and returned to the heat exchanger process. So the excess heat is released into the environment through cooling tower or other cooling systems. So control rods. So control rods are made up of barium or cadmium, which are neutron observing are used as control rods. So the neutrons available for the fission are controlled by moving the control racks in and out of the nuclear core. The steam is used to rotate the steam turbine. So the steam turbine is connected to a generator which generate electricity. So the entire reactor has been enclosed in a concrete building to prevent radioactive radiations being released into the environment. So this is the diagram of a nuclear power plant. So the this is another picture of the nuclear power plant. So it consists of a concrete shield, fuel and moderator, thermal shield, and reactor core. And it consists of a heat exchanger or boiler. And when steam passes through the turbine rotates and which is been coupled to a generator. So the mechanical energy is converted into electrical energy. The process takes place here. So after the work of the steam is been done, it passes to the condenser. The condenser condenses the steam and converts the steam into liquid or water and pumps it back to the heat exchanger. And this process keeps on repeating. So advantages of nuclear power plant. Low greenhouse gas emission. Nuclear power plants produce virtually no greenhouse gases during their operation, making them an attractive option for combating climatic changes. So high energy density. Nuclear energy has an incredible high energy density, meaning a small amount of nuclear fuel can produce a large amount of electricity over a long period. So continuous power generation. Unlike renewable energy sources like wind and solar, nuclear power plants provide a steady and reliable source of electricity, ensuring grid stability. So what are the disadvantages of nuclear power plant? So nuclear accidents. So the most prominent concern in the potential for several accidents like Chernobyl and Fukushima, which can lead to the catastrophic consequences for both human health and the environment. Nuclear waste. Nuclear power plants produce radioactive wastes that needs carefully and secure long-term storage solutions, which can be expressive and politically continuous. So high cost. So building and decommissioning nuclear power plant involves substantial financial investments and lengthy regulation process. So thank you for watching this video.